All right, here's a good problem that I thought was a good illustration of how areas of sectors could come up in real life application situations. So the Ford Model A, built from 1928 to 1931, had a single windshield wiper on the driver's side. The total arm and blade was 10 inches long and rotated back and forth through an angle of 95 degrees. The shaded region in the figure is the portion of the windshield cleaned by the 7-inch wiper blade. Find the area of the region cleaned to the nearest tenth. Okay, so the whole blade is 10 inches long. It's rotating about this vertex here, but the wiper itself is only 7 inches long. It's located at the end of the blade. Okay, and then the whole blade pivots back and forth 95 degrees back and forth. So what's the area of this region here cleaned by the blade? Well, what we're going to need to do is get the entire area of this sector that represents the full rotation of the entire blade. So this sector of a 10-inch radius circle over 95 degrees, and then subtract out this sector here, which is going to be the sector of a smaller radius circle that also rotates over 95 degrees. Okay, but what's the area of a sector? Well, we know if we use radians, we could get a nice, easy, simple formula. If we represent the angle in radians. So in radians, the area of a sector is, so you start with the full area of the circle, pi r squared, and then you multiply that by the fraction of a full rotation that the angle is. So right now we're talking about, this isn't a sector, the area cleaned by the wiper blade. We're talking about a sector being a portion of the area of a circle with respect to like the vertex. So this is a sector. The area of any sector that is based on a certain angle, that's the angle, the angular opening of the sector. The area is what? So when we multiply the full area by the fraction that the angle theta of the sector is, the fraction that angle is of a full rotation. So theta in radians divided by a full rotation is 2 pi. Okay, so in degrees this would be 360, but in radians it's 2 pi, and the pi's cancel. That's why radians simplify this formula. So, okay, area. So the area of a sector with input radians is 1/2 theta r squared. Okay, so what's the area of this sector here with circle radius 10 inches and the angle of the sector is 95 degrees? Well, let's convert that degree measure to radians. So we've got pi radians for every 180 degrees. The degrees cancel. So 95 divided by 180, 1936. So 19 pi over 36. Okay, so we've got this area is 1/2 times theta times r squared. So in this case, it's 10. So, okay, 1936 times pi divided by 2 times 100. 10 squared is 100. So let's get this as a decimal. So 82.9, and this is in what? Radians are unitless. 10 is in inches, so it's square inches. 82.9 square inches. Okay, but that's this area. That's not the area cleaned by the windshield wiper, because we need to, from that area, we need to subtract out this area. How do we do that? Well, we use the exact same formula here with the exact same area, with the exact same angle, but just the radius is going to be different. So we're going to do 1/2 times 19 pi over 36 times 3 squared. Why? Because 10 minus 7, this is 3. This radius is 3 inches. So we did 19 pi over 36 times 1/2, and now times 9. Okay, so what we want to do is we want to take this was the area of the full sector, and subtract that from this. So about 75.4 square inches. That's the area cleaned by the windshield wiper blade.